Hey there, guys. How you doing? How you doing once there? You doing okay? Well, today you're captain. You're gonna be working on some equations. All right, I'll stop doing that ridiculous accent. If you promise to work hard on multi-step equations with variables on both sides, that is what our level 2 of boot camp. Oh, sorry, not level 2. We're on level 7. Level 7 of boot camp is all about. To move up in the ranks away from being a captain to what's next up, you have to master the art of solving multi-step equations with variables on both sides. These are the big ones. These are the big kahunas. These are the ones you write home about, the ones you show to a friend and make yourself look smart. But in reality, we're just doing everything we've done up to this point all in one. So our objective is to solve multi-step equations with variables on both sides. And for success criteria, I listed all the things that we have done that you're going to have to apply. Pretty much in this order, too. I'm looking for distributive property, combining like terms, get the variables to one side, inverse operations, and remembering what you do to one side, you have to do to the other. So I'm going to start you off with a term for today, the same one that comes up in every lesson and should come up in every lesson because we're continuing to do inverses. These inverse operations, remember, they're mathematical operations that undo each other or opposites. Okay, and if you do them to one side, you have to do them to the other. So let's start off with an example here. We've got 2 times 4x minus 3 minus 8 equals 4 plus 2x. So a lot of stuff going on there. What do you do first? Well, I want you to think of like PEM does in this case. If there's a parentheses, we're going to get rid of that first. So for this example, we're going to take that 2 and multiply it by the two things on the inside of the parentheses. That is our distributive property. So we got 2 times 4x is 8x. We got minus 2 times 3, which is 6. And then everything else stays the same. Now, we've got variables on both sides, but we also got something we can simplify. If you look at the left side, I see some like terms. We've got minus 6 and minus 8. Those can combine to be minus 14. So we've got 8x minus 14 equals 4 plus 2x. Now, both sides are simplified as far as they can go. So we just have to get the variables to off of one side, essentially. So my tip for you when we did this was to find the smaller one, pick the smaller one, and subtract that from both sides. So we have an 8x on one side, we have a 2x on the other. The smaller one is a 2x. So if I get rid of the 2x, I'm going to subtract 2x. Now again, it's not division because we're not just getting rid of the 2. We want to get rid of the whole 2x. So we have to subtract that whole term. And on the other side of the equation, we have to subtract it as well. And when you do that, what's left over is 6x and then everything else. So 6x minus 14 equals 4. And hey, it's a two-step equation. We can work away from the variable first and then get to the variable second. So we're going to add 14. We're working on the left side. Add 14. We got 6x equals 18. And finally, we're going to divide by 6 on both sides. We get x equals 3. So there's a lot of steps there, a lot of things you had to remember. And the order really did matter. So I'm going to put the order on here that we just did, so you can copy that down. Here's essentially the procedure. Distributive property always comes first, if you can do it. If there's anything that needs to be distributed, it has to be done first. So multiplied, in our example, we multiplied the 2 by the two things in the parentheses. Then we got to look for any like terms that are on the same side. So on the left side, we had some like terms, and that was the only things we could combine to simplify. Then we can get the variables off of one side by doing the inverse operation to the smaller one. Do it to both sides. And then it's a two-step equation. So you work away, you work from what's not attached, and then to what is attached to the variable, and then we're done. Finally, you can check your answer by plugging back in. So make sure you have those notes written down. Essentially, this procedure here, this procedure will work for any equation that you will ever solve. Some of the steps you won't have to do, but this is essentially a comprehensive list of any equation you'll have to solve, as long as they're just with regular variables and one variable, instead of having like an x and a y. We're not working with that, so this should work. So let's use those steps to solve the second one. All right, our second example, we've got a lot going on here. This is a big equation. But what we're going to do is we're just going to take it step by step and follow what we just did. So for the procedure, we want to look for the distributive property first. So if I look here, I can actually take this 5 and distribute it to both parts on the inside. And also the second, sorry, it was a negative 5, and this 5 to both the parts on the inside there. I end up with negative 5 times 1 is negative 5, minus negative 5 times 5, which is 25, x, plus 5 times negative 8x is negative 40x, plus 5, or minus, and 5 times 2 is 10, equals negative 4x minus 8x. A lot of stuff going on here. I'm going to change one thing, and this is this minus and negative. Minus and negative always becomes a plus. Just remember that. So now, with this, we can now do step 2, combine any like terms that are on the same side. So if I look on the right side, I have a negative 4x and a negative 8x, negative 4x minus 8x, which becomes negative 12x. Okay. On the left side, I've got a positive 25x and a minus 40x. That becomes negative 15x. And then, maybe I should put those in boxes because it's on the different side. And then we also have a negative 5 and a negative 10, which becomes negative 15. So after those two steps, this equation looks a lot smaller. A lot smaller. Now step 3, get the variable to one side. So it says undo the smaller term. Again, look for the smaller one. We got negative 12x and negative 15x. Technically, the negative 15x is the smaller one. So we're going to get rid of that by adding 15x. We're going to add it over here. So we're left with negative 15 equals 3x. And now solve the remaining two-step equation. It's not even two steps. This one ends up just being a one-step equation. So we can divide both sides by 3, and we'll have our x. X equals a negative 5. So really it ended up not being too bad. 1, 2, 3, 4 steps. And we get x equals negative 5. I want to do one more example with you right now that's similar to the ones we're doing, and it is kind of a word problem, but it's these things called consecutive integers. The word consecutive means in a row. So, in a row. Meaning like 2, 3, 4. They're all in a row, one after another. So, an example might be that it says the greatest of 3 consecutive integers is twice as great as the sum of the first 2 integers. Now, that's a lot of things. But let's say we don't know what the smallest integer is, so we say it's x. Or we'll just say n. Now the second one is always going to be one bigger than it. So we don't even know what the first one is, so how are we supposed to know what the second one is? In that case, we're going to do n plus 1, because it's one bigger than the first one. The next one would be n plus 2, and so on. That's how it would technically work if you don't know what the smallest integer is. So let's just say this the greatest of 3 consecutive integers. So the greatest one, they have to be 3 in a row. So like this. The greatest one would be the n plus 2. So we're going to say n plus 2. Is, that's our equals, twice as great, so I'm going to do 2 times something, as the sum of the first 2 integers. So the first 2 integers add together. The first one is n plus, and the second one is n plus 1. So I took this one, put it in for the, and then this one in for there, added them together. That's my equation. It looks kind of funky, and it was kind of hard to figure out if you didn't understand um, the consecutive integers part. But that part was really important. Really important to know, really important to understand right here, knowing that in a row it's 2, 3, 4, like that sort of numbers. But if you don't know the numbers, it's n or x, and then plus 1, plus 2. The next one would be n plus 3. So, let's take that equation and solve it then. Once you got an equation, you can always go ahead and solve it. There is some distributing here. Actually, inside of here, we can combine this. Well, we'll just distribute first. We can distribute to three things. We've got 2n plus 2n plus 2, and the left side is just n plus 2. Now, like terms come along, and on the right side there's some like terms. We can do 2n plus 2n, which is 4n. Now, we have to look to see if we can get the variables on the same side. So, I see an n and a 4n, so the smaller one would be the 1n here. So I'm going to subtract that to get rid of it here. Subtract it here. And I've got 2 equals 3n plus 2. And I have just a two-step equation. Get rid of what's not attached. So that would be minus 2 from both sides. Again, 0 equals 3n. And then divide by 3. And you're left with n equals 0. So that means the smallest one is 0. And it doesn't actually ask a question like what are the integers, but 0 is the smallest one, so our three integers that we're talking about would be 0, 1, 2. Those are the three consecutive integers that we're talking about. And if you plug those three in, or if you plug in 0 for n, it should work out on both sides. So let's try, why don't you take this and let's pick one. Pause the video. Pick at least one of these. If not, you can do both of them. I'd like you to pick at least one of these. Try to solve it, and then unpause the video. You can see how you did. All right, let's finish up here. If you want to take a look at my work for these two, the left side I had to do some distributing first, but then there was no combining of like terms that I could do because neither side had combining of any like terms you could combine. So I just subtracted the smaller variable term from both sides, and I got negative 2x equals 2, or negative 2 equals 2k minus 12. And the last two steps would be to add 12 to both sides, and then divide by 2. I got k equals 5. Now the second one looks even longer. There is distributing to do first, so I did that. Then I looked right here. So after I distributed, I got to this point, and I combined like terms on each side. So there was a 3x and 6x on the left side, and then the minus 27 and plus 6 on the right side. So I combined the like terms. Ended up with 9x minus 21 equals 9x minus 21. And at that point, you might notice that they're exactly the same, both sides. If I subtract the variable terms from one side, I subtract the other side, they both cancel out. So I'm simply left with negative 21 equals negative 21, which is an identity if you remember from last level. If you get rid of the variable and there's nothing left over, or there's no variable terms on either side, then you gotta see if the equation's true or not. If it's true, it's an identity. Those are the same. That means there's an infinite number of possible solutions. You can plug in anything for x and it'll work. If they weren't going to be equal, that would mean that there is no solution. But for this one, there is, and it's an identity. So that all comes from our original objective, our learning goal, to solve multi-step equations with variables on both sides. And this is truly a culmination of all the different little pieces we've done with solving equations up to this point. So I hope you learned something here, and I hope you can move up in the ranks from captain to whatever's next in line. Have a great rest of your day. We'll see you later.